All right, so let's take a look here at volumes of cones. Now, this is probably one of my favorite days in the classroom where I get to show you why the cone is 1/3 of the cylinder. And unfortunately, all my supplies to make that happen are in the classroom still, where you can't go get them. And I don't have any cones laying around the house that are the same diameter as my cylinder. So hopefully you can follow this, and this will make justice for a little bit here. We'll do the best we can. Okay? So with our cone, with our only difference between this and our cylinder is just this 1/3. And the reason we are looking at 1/3 of it is because the cone comes to a little tip at the top. And so if we were to take our cylinder, let's say if I have our cylinder, we're going to draw in a cone. And they have the same radius and diameter. They're the exact same on the bottom, so I'll just draw a little blue one here for us here. So that matches. However, since all of these sides here are angled in, right? So this side here is angling in, right? And this is for the whole entire cylinder. It's for the whole entire top of this piece here. You can fit 2 more cylinders in addition to the one that you have already done. One, so we have as our main one that we just did. 2 would be your left side and right side. So you can fit 2 and 3 cylinders. Now, unfortunately, I can't show you. I would pour water into the cylinder. I would take, the cones and fill it up and show you that they're the exact same match. I'll see if there's any other YouTube videos that have already done that. But for this here, this is our best way to kind of show. So really, with all of our answers from yesterday, what we can do is we can just simply take those and divide them by 3 because we just need it to be a third. But let's at least set them so that way we know what we're dealing with. We have pi, we have our radius is 2 squared, and then we have our height of 4. And so again, as we work this out, this is our volume is going to be a total of 16.7 feet. And again, they write this one here, they wanted us to round to the nearest tenth, right? So we have some rounding to do there. And again, you can say this is approximately because we're using pi as 3.14 instead of the full-on symbol. So looking at number 2, this one here, I'll work this one all the way out for us. We're going to use 1/3, we have pi, we have 4 squared, and then we have 8, right? So we have 1/3 pi, oops, let me fix that, times 4 is 16, times 8. So again, 16 times 8, right? Thinking back from yesterday, right? If you have your notes from yesterday, even better. That's going to be 128. So again, we have a good answer. We got to keep working with it. I'm going to take 128 times 3.14. And then we got our 1/3 times 401, right? 92, right? We rounded those. So I'll round this at the end as we divide by 3. So that way we get 134 because of rounding. So this is 133.97, and the 3 looks like it goes forever. So again, this is, again, about, because we're rounding with pi. So this would be 134 cubic feet. So again, if we were to take our 401.9 and we were to just divide that by 3, we're going to get to that 134. And so for our last one, right, we can take our volume from our cylinder and just take it to be divided by 3 because there's 3 cones can fit into one cylinder. If they're the same dimension, hopefully they have 3 of them that fit in there, right? So that way we can take that, divide by 3, and again, they want us to do some rounding here. So this would be 452.16, goes on forever. We would round that 6 up. So 452.2, and this is cubic feet again. Okay, so be careful as you work. There are 3 cones that can fit into the cylinder if it's the same radius and height. So today we're going to look at our Delta Math practice. Again, it's 8 problems for you. So if you make a mistake, look at their feedback, try it again a second time to see what they need. It might be, again, using the pi symbol instead of using 3.14. So take a look, get some practice in, see how you can do.